Hey guys, welcome to another math lesson with HK Math and Science. This video will be about similar triangles, and by the end of this lesson we should all know the different tests for similar triangles, be able to choose the appropriate test that proves two triangles are similar, and finally be able to use the scale factor from similar triangles to find an unknown length. Let's just pause the video here and take a couple of minutes to write these down. Alright, so let's start us off by defining what it means for two triangles to be similar. So two triangles are similar if corresponding angles are equal, and finally if corresponding sides are in proportion or the same ratio. Alright, the similarity statement for two similar triangles is these lines here. Remember from last lesson, ABC similar to DEF. We can show that by those three straight vertical lines there, or we can use that squiggly line. And these letters are usually written in matching order, so AB corresponds to DE. So we've gone through a bit of this in previous lessons, so you guys should know what it is by now. If you're not quite sure yet, just feel free to ask your teacher at any time. So a bit like tests for congruency, we have a few tests for similar triangles, and these are side, 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 angle, 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 and right angle, hypotenuse, side. So the first one, side, 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 or SSS, is when all three pairs of corresponding sides are in the same ratio. So as you can see in this shape, all three pairs of corresponding sides are in the same ratio. To get from 4 to 8, we just multiply by 2. To get from 6 to 12, we multiply by 2. And to get from 7 to 14, we also multiply by 2. Next one, side, angle, side, is when two pairs of corresponding sides are in the same ratio and the included angle is equal. So these two angles here are equal, denoted by the same sign there. And to get from 11 to 22, we'll multiply by 2. And to get from 5 to 10, we'll multiply by 2. So that means they're in the same ratio as well. Next one, angle, 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 is when all three corresponding angles are equal. So that means all three angles, the corresponding ones, will be of the same size. And the last test, right angle, hypotenuse, side, or RHS. The hypotenuse of the right angle triangles and another corresponding pair of sides are in the same ratio. So this is pretty similar to SAS, side angle side, because technically that's two sides that are the same, and this angle is the same because they're both 90 degrees. And the sides as well, to get from 2 to 6, we'll multiply by 3. To get from 5 to 15, we'll multiply by 3, showing that they are also in the same ratio. Now let's have a go at some example questions. This question says, choose the similarity test which proves that these pairs of triangles are similar. So we're going to use these tests here. So let's start with question A. This one gives us three different angles. That's the only information it gives us, and it shows us that they are all the same size for the corresponding one. So that means this one fulfills the test of angle, 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 or AAA. Question B, we have a right angle, so we know one angle is the same, and we have two sides. To get from 2 to 6, we'll multiply by 3. To get to 3 to 9, we'll also multiply by 3. So that means they are in the same proportion or ratio. So in this case, I've got the right angle that's the same, I've got the hypotenuse that's in the same proportion, and the side that's in the same proportion. So this one will be right angle, hypotenuse, side. Next one, question C. I have two sides and an angle. These ones are also in the same proportion. 7 times 3 is 21, 6 times 3 is 18, so they're in the same ratio. And these angles are the same size, denoted by the same side. So that means the test here is two sides, one angle, so that is side, angle, side. And the last question, we have three sides. You just need to find out if they're in the same ratio. That's two, I think, yep, these ones are corresponding, these ones are corresponding, and these ones will be corresponding. To get from 2 to 6, I multiply by 3. To get from 4 to 12, I can multiply by 3. And to get from 5 to 15, I multiply by 3. So this one, they're all in the same ratio or proportion. So our test is side, side, side here. Alright, now moving on, pause the video here. Have a go at these ones by yourself, and just unpause the video when you're ready to go through them with me. So starting with question A, we're given two sides and one angle, and we need to find out whether these sides are proportionate to each other or are in the same ratio. So there's no real way to get from 2 to 3 by multiplying, so I'm going to write them as fractions. Write the corresponding sides as fractions, so that's 2 and 3, these are corresponding, and 4 and 6. And if you simplify this, get rid of that, these are the same fraction. If you simplify 4 over 6, that also becomes 2 over 3. So this means they are in the same proportion. So we have two sides and an angle, so that is the test, side, angle, side. Alright, now moving on to question B. The question gives us three sides. We just need to find out whether they are in the same ratio. So I'm just going to write the corresponding sides. The first one is 2 and 4. These two are corresponding. Next one is 3 and 6. These two are corresponding. And the next one is 5 and 10. Those two are corresponding. So if you simplify these fractions, they are all the same as one another. They all become 1/2 at the end. So this means this satisfies the test side, side, side. Give yourself a tick for each one you got correct so far. Now moving on to question C, I've got a right angle and two sides. So we just need to find out whether the two sides, the hypotenuse and the other side, are in proportion to each other. So our first set of corresponding sides is a 3.6 and 1.8. So I'll just write the smaller one first. And we have 3.4 and 6.8. These fractions equal each other. Once again, if you simplify them, they both become 1/2. So this satisfies the test RHS, or right angle hypotenuse side. And the last one, we have three angles that are exactly the same, denoted by the same signs for the angle. So this one simply satisfies the test AAA. Give yourself a tick if you got these two correct as well. Alright, so now moving on to the next question. For this pair of triangles, we have two triangles here, one there, and a smaller one on this inside. We have to give a reason out of these four why the two triangles are similar. Alright, so straight off the bat, I know it's not going to be RHS because this isn't a right angled triangle, so let's cross that one off. And having a look at these two triangles, we know that it shares one angle, so this angle is going to be the same for both the bigger triangle and the smaller triangle. So we have an angle that's common, and also we have two parallel lines here. This is a very key piece of information. And because these two lines are parallel and it shares this line, it shares the A to C line and the E to C line, it means these angles will be the same and those angles will be the same. So the test F fulfills or satisfies is AAA. So the answer to question A will be angle, angle, angle. Now moving on to the next question, we need to find the value of X. So that's the side length E to C there. And because we now know that these two triangles are similar to one another, we just need to find the scale factor of these two corresponding sides and apply it to these two here. So our scale factor here will be 3 divided by 2, or 3 over 2. That gives us 1.5. And to get X, or the length of E to C, we'll just simply multiply 5 by 1.5. If you work that out, that will give you a side length of 7.5 centimeters. Alright, now it's your turn. Just pause the video here. I haven't got this one by itself. It's a similar type of question to the one before. If you do get stuck, just please ask your teacher in class. Alright, so question A, give a reason why the two triangles are similar. Alright, so if you remember from geometric reasoning and parallel lines, these two are parallel lines again, and we have one line intersecting like that, and we have another one intersecting like this. I'll use two separate diagrams here. So our first set of angles, I'll have a look at this one and that one. In this, it would be that one and this one here. So if you remember, this is known as an alternate angle, and in parallel lines, an alternate angle are the same. So we know this angle here and that angle here equals one another. And for the next pair of angles, I'll get rid of the markings from previously so it's less confusing. We have the one up here, this angle here, and that one here. So if you have a look at this parallel line, this angle here is that there, and this angle here would simply be that one there. So in this case, these are also alternate angles, so that means that angle and that angle is the same as each other. So far we've got two angles. So that's looking like it's going to be angle, angle, angle. We also have another angle that's the same. This one's a bit easier to see. If you remember vertically opposite angles from angles at a point like that, these two angles are the same as one another, and those two angles are the same as one another. You can see that happening right there. So these two angles will equal one another as well. So for our first question here, our reason will be angle, angle, angle. Now we need to find the value of X. Let's go to question B. So this is using the ratios of the sides again, because we know that these two triangles are similar now. So our set of corresponding sides, we have 2 and 6. We're trying to find X. I'll use the bigger one on top. So our scale factor is 6 divided by 2, which equals 3. So to find the size of X, we're going to have to multiply 3.5 by 3. And multiplying 3.5 by 3 will give us a value of 10.5. So this will be 10.5 there. Give yourself a tick for each one you got correct here. Alright, so that brings us to the end of this video. Hopefully you guys now know the test for similar triangles, can choose the appropriate test that proves two triangles are similar, and finally can use the scale factor from similar triangles to find an unknown length. Thank you guys for watching, and I'll see you guys all back online.